This is going to be the recap of the 2 lectures that went into Lab 3 for the Unity 1 course. This is specifically from summer semester of 2021 in case things have changed in a future class year. Yeah, so I'm just going to quickly run through the material that we covered for those 2 lab periods in case you need a little bit of a review before your final project or to wrap up your Lab 3 projects. First things first, I've got a floor already built here, and if you remember for this lab, what we're doing is we're effectively making an infinite runner where our player is going to stand in one place, things are going to slide in from off the screen, and we're going to have to jump over them. Because this is a shortened lab, it's not going to become too complex of a game. It's more going to be used for demonstration purposes of some basic concepts. But if you have time to make it more difficult by, say, ramping up the challenge, things like that, that will get you an advanced grade. So I've got a floor here. I'm actually going to give it a quick material to make it a little easier to see. Just call this the floor material. And just make it kind of a general gray. That'll be a little bit easier. And then very boring. A lot of you I know got actual models from the asset store, went out to the internet and found them to make it more fun. I'm just going to use a cube because I'm mostly just going to be demonstrating the coding concepts here. So here we go. Here's my player. Done this many times before too. First thing we need to do, give them a rigid body so that they have gravity. Just check that that works. It did. That looks good. I'm just going to align them in the middle because why not? There we go. Okay, and I already have a player controller script I created here. Pull that onto the right screen. Nothing's in it yet, but pre-created it so you didn't have to wait for it to load. And the first thing we're going to do is add a key so we can make our player jump. And I'm going to do that by creating a public instance variable for my jump key. As a reminder, if I've made an instance variable that's public, it will actually show up in the Unity editor as something I can edit. So I'm going to rename this cube to be player so I remember which one's which. Give them the player controller. And because key code is something that already exists in Unity, it knows how to display that here. So I've got this drop down and I'm going to make that space. So you could do that in code form, but oftentimes it's useful to be able to go play around with your controls, and just exposing it like that lets me use the drop down and change it anytime I want. Now, in the past, when we've done movement, we've done it using transforms, transform.translate. And transform, as you've seen before, is a component that every single game object has, which is why I can call that transform and call its translate method on it. We're going to do movement a little bit different this time, because generally speaking, when you're doing a jump, you probably don't want your jump action to be disappearing from the bottom of your jump and instantaneously reappearing at the top of your jump. So if you did a translate by the jump height you wanted, your player would just disappear, reappear at the top of their jump, and then fall to the ground. We don't want that. We want it to be like a physics interaction. So we're going to do that instead using the rigid body, because the rigid body here is what's responsible for application of forces and managing drag and gravity and all of that. So what we want to do instead is we're now going to apply a force to this rigid body. The problem is, unlike, so let's say, I'll go ahead and do the code for checking if the jump key has been pressed. So there we go. It's an easy check of if this frame we've pressed down our jump key. This code will execute. If we did it in a translate, we can just do this transform.translate. The reason we're allowed to do that is because every game object has a transform, so you're always going to be able to call transform on there. Rigid body is different, because if I try to do this right now, you'll see that it autofills the class rigid body, but it knows nothing about the rigid body applied to the game object. So what we're going to need to do here is we're going to need to actually get a component off of a game object, and there's a method to do that. I'm going to make another instance variable. This one's going to be private because I'm going to get it through code instead of getting it through the Unity editor. So I'm going to make it private just so I can't accidentally change it in the editor later. The type, if I could spell correctly, is type rigid body, and I'm just going to shorten that to RB. So rigid body, remember that components are all actually scripts behind the scene, which means the name of the component is the name of the class. So there's a class called rigid body, which is why it lets me make a variable of type rigid body named RB. Problem is it's not populated with anything, so we need to actually get the correct rigid body and assign it to that variable. And the way you can do that, I'm going to do it in start because you only want to locate it one time at the very beginning of the game execution. We don't need to be going out and searching for our rigid body every time we want to use it. What you're going to do instead is just at the very start of the game running, you'll look for the rigid body, you'll find it, and you'll assign it to this variable so that for every frame in the future, every time our update method runs, we already have it. You don't need to go out and look for it again. And there's a method called getComponent. And what getComponent does is it will go out and it will find the component of type whatever on a game object. So this syntax is a little weird. You haven't seen this before. Those angles there tell you what class type it's searching for. Don't worry too much. It's a thing called generics that we're not really going to get into, so don't worry about it too much. But for now, all you need to know is that you're getting component of type rigid body, and then just this open and close parentheses because this is a method. Methods take arguments. This one takes no arguments, so just open close parenthesis, and you're good. This is actually, I didn't mention this in the actual lectures for the normal class period, but getComponent is working on a game object. So if I actually had a different, let's say I had made another, let's say I had a variable for some other game object here. If I wanted this object's rigid body, I can do this. It's a bit of a tangent. You don't need to do that for the purpose of this lab, but just so you know what's going on here, because I haven't added any object before it, it's referring to this object. Whatever object this script is on, which in this case is on my player, that's the rigid body it's going to get. If I had instead referenced some other object, I could get the rigid body off of that object, but don't worry about that too much for now. The important part is I'm getting the rigid body component on this game object. Now that I have that, instead of, and I'm actually going to get rid of this quickly, instead of using the transform to do our jump, we can use the rigid body to add a force to do our jump. And you do that with the rigid body method called add force. And force takes in a vector 3. It's actually, if I click through this, you can see it's got a couple different ways of calling this. This is the one that I'm going to use for the purpose of this lab. It's add force, and it takes in a vector 3 and a mode. You'll see in a second why that mode is useful. So I want to apply force. Well, we probably want to do it in the up direction. So we can apply a force up. And as you saw from the arguments, this is a totally valid way of doing it. I can just add a vector that I want to use as my force to apply. We probably want to have some control. Seen this many times before. Let's just start it at like 5. You want some sort of variable that we can use to change the force of the jump, because right now we have no idea how hard it's actually going to jump when we hit the space key. And we can multiply this by the jump force, because this gives us a way in our editor to kind of play around with it and see how high it's going to make us jump. Let's actually see what that looks like quick. So if I come back over to Unity, my jump force you can see is there, and when I jump, it does basically nothing. If I up this to like 200, there we go. Now we got a little bit of a jump. 500. That might be a little bit high, but it's a bit more reasonable. The thing is, I'm actually going to lower it back down because this is where that force mode I mentioned comes into play. There's a second argument you can take, and force mode is what's called an enum, which means it's a preset selection that we can pick from. And you can see from my autofill that we have 4 options of force mode: acceleration, force, impulse, and velocity change. They all behave a little bit differently. By default, the one we were using is acceleration. If you don't give any argument, it uses the acceleration force mode. And what this means is it add a continuous acceleration to the rigid body, ignoring its mass. So it gives you a brief description there. The important part about that being it's a continuous acceleration. So when we pressed it, the reason it didn't go very hard, because you'd expect if we were applying a jump force of 100, it should be a significant power. But it was acceleration, meaning it's continuous, which means that number has been divided over the period of time. Not really super critical, but a cool thing to know about Unity is that it's doing all of these calculations based on real physics. So that's why the acceleration is shortened. So if you wanted to be able to hold a button and gradually apply that acceleration until they were going up to some certain speed, acceleration would be a better option for you at that point. But a jump is different. You don't want to like accelerate continuously. There's going to be one action where all of the force is applied at the same time, and you apply it instantaneously. It happens, it jumps, and then the force stops applying and it falls back down. So what we actually want to use is impulse here. Force is also, actually, impulse and velocity change are both instantaneous. The difference being velocity change ignores mass, impulse uses mass. So I like to use impulse just because then we can take into account the mass of different objects. So we can apply the script to something heavier. They're going to need a stronger jump force in order to be able to jump. I just like using it that way. And we should now see, since I made that change, when I go to jump, now that we're using impulse mode, there we go. We're only on 5, but it's already a much better jump. It kind of seems like 10 is probably going to be a better bet for being able to jump over something. Maybe a little too high. Let's call it 8. There. 8 seems like it's enough to get us a good jump over some object sliding in from the right of the screen. So with that, we've found our rigid body on our object, and we've used our rigid body to apply a force to get us to do a jump, an impulse force. So you apply a force instantaneously, we jump, we fall back down. One problem you might recognize right away with this, though, is the fact that currently I can jump as many times as I want midair. I can apply that force whether or not I'm standing on the ground, and that's not really how jumping works. I can just apply a force whenever I feel like it. Some games have double jumps. That's actually something you could probably implement as a extension onto Lab if you wanted to, being able to keep track of and allowing one additional jump, but only one additional jump. To do that, though, we need to start keeping track of if we're allowed to jump or not. So probably what seems like a good variable type, if we want to know, are we currently allowed to jump? Well, that's a binary option. Either yes we can or no we can't, true or false. So I'm going to make a Boolean variable. I'm going to make it private because I'm only going to want to manipulate it in code. I don't want to change it in the editor. And I'm going to call it isGrounded. So if isGrounded equals true, that means we're currently grounded. We're standing on the ground. If isGrounded is false, we're in the air. We're not standing on the ground. We'll make this easy, and at the start, we'll just say isGrounded is true. So at the start, just assume we're standing on the ground. Technically, that's not quite true. We're a little off the ground, but we can easily fix that by just shifting ourselves down a little bit, and now it's close enough that we can just pretend we are. Okay, well, when are we no longer grounded? We need to keep track of that, because right now we would just set to true, it would always be true, and everything would always work the same. Except now, whenever we jump, we want to switch that to false. We've jumped. We're no longer grounded, so we're not allowed to jump anymore. At the moment, still going to function exactly the same because isGrounded will be set to false, but we're never doing anything with it, which is why we need to alter our logic here to say that we're only allowed to jump if the jump key was pressed, and we're currently standing on the ground and is grounded. You might be able to guess that now we're going to have a different problem, which is at the start, is grounded as true. In fact, we can actually, I made it private so we can't see it, never mind. But is grounded should be true currently, which means if I hit space, we should be able to jump. It switched to false, I hit the ground, except now it switched to false and it never switches back again. So now I can just never jump ever again, which isn't exactly what we want. Well, how do we know when we're grounded again? There's an event that'll notify us, and that's when we actually hit the ground. So we want to check for collision. If you remember from Lab 2, Unity has this onCollisionEnter method for a game object. And so this code should automatically trigger anytime we detect a collision with something. So let's just say we've collided with something. Well, now we're grounded again. Is grounded as true. And let's try it. We jump, we hit the ground, and we can jump again. If I try to jump in midair, it doesn't work. I also forgot to increase my jump here to 8 when I'm not running the game. So that seems to be working. We can now only jump once until we touch the ground again, and then we can jump again. The problem is we're doing this on any collision. So if I were to bump into another player or bump into a wall or hit my head on the ceiling, that would detect as a collision and I'd be able to jump again. So you could jump, hit the ceiling, and then jump again without ever touching the floor. So you could just press yourself into the ceiling and never leave. So we want to make sure that we're only switching it to is grounded if we've collided with the floor. We could check if we've collided with this object, but in a realistic game, odds are pretty good. You're going to have multiple things you could be standing on. So let's pretend our floor was made of a bunch of different models. We're going to be able to want to detect if what we collided with is anything that counts as being allowed to jump. We're going to do that using this thing called a tag. You've probably seen this at some point while editing your objects in your game. You've got the name field here, but there's also this thing called tag that has just always said untagged for us. And it's got a bunch of options to pick between. So I've actually already added the one that we need here, but if you don't see a useful one, you can click add tag, and it gives you this list of tags here that you can hit plus. Let's say I made a new one called another tag. It's not going to use that one because we've already got the ones that we need, but I've added these in the past. This means that I can tag this one, the floor, with the ground tag. So I've now told the game that this counts as ground. So now we not only want to, we detect we've collided, we want to make sure that what we collided with is actually something that counts as ground. Well, this collision here that it's passed in, .gameObject, is actually a reference to the thing we've collided with. So it's got a bunch of options on here, but GameObject is the one we want. So collision.gameObject.tag, because a GameObject has a tag. If that tag is ground, then we set is grounded to true. So now anytime I collide with something, I'm going to check, is the tag on that thing I collided with the ground tag? And if so, now I'm grounded. Not in the I got trouble sense, in the I'm standing on the ground sense. I think every time I say that, I'm grounded. Makes me think that. All right, so it still seems to be working. Can't jump while I'm in the air. But just to prove that this actually works, let's add another object above it so I have something to bump into. So if that didn't work, what should happen is I should bump into this and then immediately be able to jump again. Let's try it. And nope, I still can't jump until I hit the ground again. as I go bouncing off at a weird angle, which I know is something a lot of people ran into also. It can be kind of fun, but if that's not what you want your game to do, worth mentioning, rigid body has these constraints on it. So I'm actually going to freeze its rotation so it can never rotate, and I'm going to freeze all of its positions except Y. So I've now made it so that my player can only go up and down and it can't rotate. And just to show that, seems to be working. And that was everything up through the end of the first half of this lab, the first lecture. So I'm just going to roll straight into what was the content of the second lecture of the lab, which primarily has to do with creating UI and keeping track of score and linking actions across scripts. I guess another thing I probably need to do is I need to make a spawner. You've done this in past labs, so I'm just going to do it again really, really fast. Use another queue because I don't want to do anything too complicated. Make it a little bit wider. There we go. I might actually want to change that. I'm going to change it so that this way, looks like -90. The reason I'm doing this is because I want to just be able to cheat and use forward on this object as the direction it's moving, so I rotated it until its blue arrow is pointing that way. So I'm actually going to change this and stretch it out that way. Move it onto the ground. Another thing I need to do is I need to give this a rigid body because I want it to have physics interactions. I'm going to want it to detect collisions, but on its rigid body, I'm going to check this is kinematic. Is kinematic basically means that none of the forces applied to it are going to do anything, so it'll only ever be moved by our code. If it bumps into our player's not going to be able to slow it down. It's just going to keep going. Gravity's not going to affect it. I'll show that now by just running the game. So you can see, even though it's got that rigid body, and even though its rigid body has used gravity, it's not actually falling because it's kinematic, which means none of the physics calculations are actually going to apply to it. Only our own movement. Okay, back to the really quick. We've done this in the past. I'm going to make an empty game object. Call the spawn manager. And this will be a nice recap of Lab 2. Make a new script. Call this the obstacle controller. Open that up here. Well, first thing we want it to do, we want it to move forward. So let's make a speed variable. Start at like 5. What do we want it to do every frame? Well, we want it to move forward. Transform, translate. I pointed it the right way, so I can just use vector 3.forward times time delta time times our speed. No input required. It's just going to always move forward at its speed multiplied with the change in time. Let's try it. Should probably name this our obstacle. Give it the obstacle controller script and go. Yep, and it moves forward and it shoved our player through the floor because it's kinematic. Now that I have the obstacle doing what I want, I'll make another script for our spawn manager. Put the spawn manager script on our spawn manager object. After it loads, there we go. Come into our spawn manager. So if you remember this, a game object for our prefab that we're going to be spawning. And you can always reference this code in the Lab 2 worksheet if you don't remember how this works. I'm going to make a new method called spawn. And in spawn, I'm going to create one instance of that prefab. Well, now I want it to spawn on a cadence. So up here in start, I'm going to set up an invoke repeating. The method is called spawn. We'll start after 2 seconds and we'll spawn every 2 seconds. Easy enough. We got a prefab. Every 2 seconds, we're going to create one of those prefabs. In the past, when you've done this, you've put other things here. So you could put like a vector 3 for the position you want it to be in and things like that. I actually, because my prefab which I haven't made yet. Take my obstacle, drop it in my prefab. There we go. I can delete this now. Because my prefab here has this position that's actually where I had it before, I'm just going to leave it like that because it means it's going to spawn at that spot every time. I'd probably want to adjust it to have it off the screen, or you could use your code to randomize where it's spawning. But let's just see if this works. It doesn't, because I never assigned the prefab there. Should, after a short delay, there we go, spawn one. Great, it seems like it's working. Might space those out just a little more so that I have more time to react to it. I did not make the time dynamic, so I have to change it in code. That's another reason that it's probably useful to make a public variable for the spawn interval so you have easier control over this from the Unity editor, but oh well. And on our game, I should be able to jump over it. Game runs, 2-second delay, spawn, jump, jump. It works. Not the most exciting thing in the world, but it works. All right, all of that was really set up for the fact that now what we're going to want to do is be able to keep track of a score. For example, in this simple case, how many obstacles have we successfully jumped over without crashing into any of them? And what we need in order to do that, first of all, is actually some text to display the current score. In Create, you've got this UI category, and there's a field called Text Mesh Pro. Text also works, but Text Mesh Pro is a slightly more advanced version of it. I recommend using that. If you haven't done this yet in your project, it's going to ask you to import something called TMP Essentials. Hit yes, you need to import that for this to work. I'm going to give this object a name. I'm going to call it score text. And so you can see down here, it's actually appeared in the lower left of my game window. Looking for it in the window though, there it is. So it actually does exist in the world. It's just really, really big. And if I zoom extremely far out, you can see this box here. That is my window. So the way Unity renders UI, if I stretch this up and down, it's kind of hard to tell because it's resizing, but the ratio up here is also changing. That's because Unity places UI into the game scene, set up such that it's 1 meter of game world space for every 1 pixel of your display space. So let's say my display down here was 1,000 pixels wide. This white box in the scene would be 1,000 meters wide. And it lets me interact with it the way I would with any object, where I can click on this text, I can drag it around, I can place it wherever I want. So let's just put it, I'll put it up here where it's hard to read so that I can demonstrate. You can also click on this vertex color over here, and that will let you change the color of your text. So something like that, that's much easier to read. It's also got this field here where I can type whatever I want. I'm going to leave it as new text for now, or I'll type hello. So you can see I edited my text thing. I can resize it. I can make this font size a little bigger. Something like that. Sure. But what we want to be able to do is we want to be able to update the text through a script that's keeping track of our current score. So back to our scripts, I'm going to make another new one, and I'm going to name this Score Manager. And then I'm going to make a manager for it up here. Something I often like to do to keep track of all of my different managers that I've stuck on objects is make a hierarchy where I make a manager class and put the spawn manager under there. Then I'll make a new one called Score Manager. I'm going to put that under here too. You can put more than one of these managers on the same object. I like to have them on different ones just because it's easier to find where they are, and it keeps this very empty. Doesn't matter too much, but this is the way I like to do it. And for the sake of making this a little clearer later, I'm actually going to change this thing's name to Score Manager Object. I'll do the same here. You don't need to, but just so that in scripts in a second, when I type Score Manager a bunch of times, it's more clear if I'm talking about this object or this script. I'm just making sure they don't have the same name. For my own games, I usually give them the same name, but for demonstration purposes, I'm going to separate those out. In my score manager script, the first thing you're going to need to do is up at the very top under where you have all these using statements, put using TM Pro. This is using Text Mesh Pro. You have to put that for Unity to know that it's allowed to use these classes, or for it to even know what the classes are that you're referring to. And that TM Pro includes all of the Text Mesh Pro classes. Make a public instance variable, like we've done many times now. But the type is going to be Text Mesh Pro UGUI. Score text. This is the object type you want in order to use that text field. You're just going to kind of have to remember or reference back to what this class is for now, since it's not just called text field or something, unfortunately. As we've seen with public variables before, this should now mean over here in my score manager, which if I give it the score manager script, there's the field that I added for score text. It takes in a Text Mesh Pro UGUI, UGUI, and I can drag and drop my score text into there. So now this variable refers to that text field, and it will let me do things like this. At the very start of the game, let's set the score text, which has a method called setText, to display our starting score. So at the very start of the game, change our text field so that it shows that we have a score of 0 when the game first starts running. Currently it says hello, and you should be able to see when I run the game. Maybe. There we go. There we go. It updated and it now says score equals 0. Awesome. But now we need to be able to actually update that score. So next thing I'm going to do, I'm going to make an integer variable called score. And at the very beginning of the game, it's going to be equal to 0. And in fact, I'm going to change this a little bit so that instead of saying the 0 explicitly, it's just going to set the text to score, :space, and then whatever our score variable currently is. We need to be able to update that score though, so I'm going to make a method on here because we're going to be it'll be a different class that knows when that score changes. We're actually going to know that our score changed because our player is going to detect a trigger, and the player is going to have to tell the score manager, hey score manager, I jumped over something, add a point for me. To do that, I need to make a public method. It doesn't need to return anything, and it's called add score. Or let's call it add point. If I instead wanted to have variable amounts of score that they could detect, I could have this take in an argument for how many points it adds. But for this simple game, we're just going to assume that it always adds 1 point and not worry about it. So first thing that happens when we add a point is we add a point. If you've never seen this syntax before, this ++ is the same thing as saying score equals score plus 1. It's just a shortcut for that. It also works to say score plus equals 1. I think C# lets you do that. It does. Okay, so we increment the score, and then after we increase the score, we actually need to do this again. Because if we're just increasing the score, but we're not updating the text is never going to change. So let's go back to our player, because as I mentioned, our player is going to be the one who actually knows about the score update. And just to show how this works, I'm going to check for a key press, just to show that I can press a key and get that score to go up. Let's just say, sure, I hit the A key, the score should increase. But in order to do this, we need to have some reference in the player controller to the score manager. We could do it by creating a public variable, but we're going to actually search for it this time. So let's actually come down here and make a new private variable of type score manager, because what we're trying to do is we want to get a reference to this, and the class is score manager. So I'm looking for something of type score manager. Call that one SM. So how do we get the score manager? We can't just do get component like before, because the score manager component isn't on our player. Instead, we have to first find the object that has the score manager component, which we called score manager object here. So I want to look for this object, and once I find it, I want to get its component. So I want to find the object, and to do that, I can use this method. Game object dot find, and then I pass it a name, and the name of the object is score manager object. This is why I changed that name a little, to make it more clear that what we're looking for is the object first. And now that I have the object off of score manager, I have the score manager object, and I can search it. For that component. I'm going to move these down to the end to make them a little more clear. So to recap what's happening in this start method, first thing we're doing is we're searching, this is the player object, we're searching ourself for the rigid body component, and then after that we're searching for the score manager object, and we're searching that object for its score manager component. So those two variables now reference, the rigid body variable references this rigid body here on player. The score manager finds this object and references this component here. So those are the two things we're going to be interacting with. Now that we have this, what we can do is add a point to our score manager, because we added that public method, which means we can see it. So we have the score manager, and we can call add point right here, because we're allowed to see it. Let's just see if that works. I think I assigned the A key to be what we use for that. The game is running. There you go. Every time I hit the A key, the score goes up, and it updates the text display. You can see it wrapped around when the text got too long. If you don't want it to do that, this text actually has these boxes on here. You can use these to drag and make it wider so that that doesn't happen if you don't want it to. Great. So now we can keep track of the score. Instead, what we want to do is actually detect if we've jumped over something. And there are a lot of ways you can do that, but the one I'm going to do is I'm going to actually use a collider to detect if we've passed through the area of space above an obstacle. Sorry if you can hear the thunder right now. To do that, I actually need to go to my prefab here, and I already turned it into a prefab, but you can edit prefabs if you just double click on them. It opens in this window here where you're editing just the prefab by itself. So it's got this one box collider on it. I'm going to leave that. That's how we detect if we've crashed into it, and it's what actually handles physical collisions. But I'm going to add a second box collider. You can have more than one box collider on an object. And I'm going to edit this collider to make it taller. Like that. And I'm going to switch it to be toggled as isTrigger. So two things isTrigger does, if you remember this from lab 2. Instead of the onCollisionEnter method firing, onTriggerEnter will fire anytime we pass through it. The other thing is you'll pass through it. You won't collide with it. If I didn't tag isTrigger, you would hit this invisible wall and stop. Instead, what we want to do is we want it to be a trigger. You pass through it, and it calls the trigger code. To show you that that does exist, if I run the game now that I've made that update, because I made the edit to the prefab. Oops. You get down here. So there you go. If I select one of these prefabs I'm creating, you can see the collider is actually there, extending way above it. So back in my player controller, I can now, we've got this on collision enter, checking for when we've collided with the floor, or anything for that matter. Well, now I'll add the one for on trigger enter. And in this one, if I have entered the trigger, I want to add a point. So now instead of adding points with a key press, anytime it detects that we've passed through a trigger, we're going to add a point. And let's just see if that worked. Run the game. Wait a second for it to spawn. And there you go. Anytime I jump over an object, I pass through its trigger, and that trigger causes my score to go up by 1. Last thing we want to do, second to last thing we want to do, is we need to detect if we've lost the game, which is anytime we collide with one of those objects we're jumping over, we need to lose the game at that point. So I'm going to go to my obstacle prefab, and I'm going to give it a tag because, we've already created the tag for it, forgot about that. I'm going to tag it as an obstacle because I now want to be able to detect in my collision, did I hit the floor? Great, then I can jump. Did I hit an obstacle? Well, then I lose. We need some way of displaying that we lose though. So back in my canvas, I'm going to add another text mesh pro field. And this will be my game over text. And I'm just going to go ahead and make it say game over. Maybe make it much bigger, and it now extends way beyond the thing because that field's too small. But if I stretch this out a little bit, there we go. Got some text that says game over. Make it a nice visible red color. But I don't want this text to be showing all the time in the game. So actually in this object up here, I'm just going to click this little checkbox toggle to turn it off. So this is the active checkbox. This is inactive. Now it's active. At the start of the game, I want it to be inactive. But in my score manager, now here's a weird thing. I could get another of those Text Mesh Pro U GUI objects to actually refer to the text field. But in this case, I actually want the game object it's applied to. So even though this contains a text, I'm getting the object. And to make that a little bit more clear, what I'm going to save in that is not this Text Mesh Pro component. I'm going to save the game object itself because I want to reference this checkbox, which is part of the game object, not part of the text component. A bit of a specific and odd difference there, but it's an important one. So this whole part up here belongs to the game object, so that's what I'm turning on and off. I made it public, which is good, because that means I can come to my score manager and I can assign it that object. And now I can add a new variable, or not variable, method, that I will call game over. And whenever something calls the game over method, what I want to do is take that game over text object and set active to true. So at the beginning, active is false, you can't see it. But now if something calls game over, I want to switch active to true. And when do I want to do that? In my player controller, on collision enter, if it was the ground, I set as ground is true. Else if it's an obstacle, I want to call score manager's game over method. So now if I collide with something, if it's the ground, I can jump. Otherwise, if it's the obstacle, then I call game over. And in game over, I take that object that says game over as the text and I make it visible. And let's just see if I did this right. So here we go, the game's running. One obstacle comes, I jump over it, I get a point, and then if I let the next one hit me, boom, game over. So it seems like it's all working. Did I accidentally leave the trigger on, or is that because it's kinematic and through the floor? Nope, it's off. Okay, good. The only other thing you might want to do is you might want to be able to reset your game, reload the scene. Loading scenes is also how you can load multiple different scenes within the same game. So I'm going to do one last little thing here, and let's say if my game's ended, I want to be able to restart it. So I'm going to add in my Square Manager, if you press the R key, I want to reload the game. Well, here's another import we need to do. We have using TM Pro already. This time I'm going to do engine.scene management. So you need to import Unity engine.scene management in order to be able to use that. And for scene management, what you do is, and this is where I'm going to double check the lab worksheet because I forget every time exactly what the syntax for this is. But what we're trying to do is we need to get the active scene. Let's see if I can just remember it. Scene manager dot get active scene. That worked. I might actually remember it. So we get the active scene, which is the scene currently running, and we save it. And then we use scene manager to load a scene, which loads it by name. So you can load it by the scene name, which in this case is the name of the active scene. So this should now mean if I run my game, I start out, I get a game over, and then I hit R, it reloads the scene and starts over. My lighting went weird because I haven't added it to the build index, but don't worry about that for now. And that's it. That's the entirety of Lab 3. So hopefully this helps with wrapping up the last of the lab. Of course, ask me if you have more questions. Sorry it took me a bit to get this video up. I had to re-record it. But yeah, good luck and looking forward to seeing you all in class.